So finally, we have come to the last chapter syllabus, chapter 29, Declarative Programming. What are the learning objectives? By the end of this chapter, you should be able to show understanding of and solve a problem by writing appropriate facts and rules based on supplied information. Writing appropriate facts and rules based on supplied information. So in this declarative programming, we use facts and rules. Facts are real facts which are true, and rules, how the fact should be used. So understanding of and write code that can satisfy a goal using facts and rules. So in declarative programming, we use the goals. We set a goal for the program to come out or bring the result. Declarative programming languages. They include database query language, such as SQL. We know what SQL is. Stands for Structured Query Language. They are used extensively in DBMSs, databases. How to create database, how to create tables, to set up the fields, the table structure, how to set up primary key, how to insert data, to delete, to modify the structure. All those things can be done using SQL. And regular expressions, like even this kind of expression, the logic programming. Logic programming is what, like Prolog, a language called SWI Prolog. That is what we are going to use in this chapter. And that is also declarative programming. And functional programming, based on mathematical functions and various functions like that. Functional programming. So there are 4. Prolog is a logic programming language widely used for artificial intelligence expert system. Prolog or logic programming. The name has come like that. Logic programming language, Prolog. And the name here is SWI Prolog, the particular one we are using. And it's used for what? Artificial intelligence and expert systems. So it sounds interesting, isn't it? When we start, you can download and install SWI Prolog. Then when you load it, you will get this screen. Welcome to SWI Prolog. Here it is. Right, so this is the prompt. This is the environment. Prolog basics. Let's learn the Prolog basics. There are 3 basic constructs in Prolog: rules, queries. Repeat: facts, rules, queries. We have to set up the facts and rules, and queries are the goals, and we get the information out. The program logic is expressed using clauses. And the clauses means facts and rules. So these two, the facts and rules, they are called clauses. And problems are solved by running a query or goal. So this one is to solve the problem. Problems are solved by running a query. Collection of clauses is called a knowledge base. So you may have heard the term knowledge base instead of database in a normal programming or in a program or a computer system. This is knowledge base. Writing a Prolog program is writing a knowledge base as a collection of clauses. So collection of clauses is the knowledge base. We use the program by writing queries. After writing the program, the knowledge base, and we use the program by writing queries. Clauses of the form head, this, and body. So what? This one consists of the head and body. Clause always terminates with a full stop. So that's a format. Head, this symbol, body, and the full stop. So here, if you look at it again, facts and rules are the clauses, and they are made of the head and body. Then queries, goal, knowledge base, term. So these are these are summary of what we learned. Term, we didn't learn it. Now we are going to learn the next one. Prolog has a single data type called a term. A term can be a general purpose name with no inherent meaning that always starts with a lowercase letter. Right? So remember the rule, an term, a general purpose name with no inherent meaning. There's no meaning in that, but always starts with a lowercase letter. Then it can be a number. What can be a number? A term can be a number. Integer or float. A variable denoted by an identifier that starts with a capital letter or an underscore. So a variable starts with capital letter. A term starts with simple or lowercase. Variable starts with capital letter or underscore. A compound term, a predicate, consisting of an item and a number of arguments in parentheses. So a predicate is a compound term. Predicate has an arity, that is the number of arguments in parentheses. Prolog is case sensitive. So the number of arguments in the parentheses is called the arity. How many? Right? Arity. Prolog is case sensitive. So here, term can be an atom. Start with lowercase letter. A number, variable start with uppercase letter or underscore. Compound term, atom and arguments within parentheses. Atom and argument. And is the number of arguments in the parentheses. Predicate. Predicate is the next one. A predicate has an arguments in parentheses. Prolog is case sensitive. Which has the arity. The arity. And that is the number of arguments in parentheses. Predicate has an arity. So I'll say has because otherwise it's not correct. It has a thing called arity. It has an arity. That is, the meaning is the number of arguments in parentheses. So the predicate has the arity. Facts in prolog. Facts in prolog. So let's start with a small set of facts. So let's have the facts in prolog. A clause without a body is a fact. Clause without a body is a, we are looking into the only the first part only, body, without a body. For example, capital city, Paris is a capital city. That's how we read when we have a statement like this. Paris is a capital city. Berlin is a capital city. Cairo is a capital city. So capital city, Paris is a capital city is a compound term. Why? We learned about compound term earlier. It's a predicate. Predicate is a capital city. And remember, predicate has an arity, the number of arguments. So here is one argument. Paris, capital city, Paris. That's a predicate. And the argument is this. Both capital city and Paris are term. The Paris is the argument. Within parentheses is the argument. It's an atom. Atoms start with simple letters. Capital city has arity 1, as it has just one argument. This can be written as capital city /1. The /1 showing that it takes one argument. Take a new file, type the clauses, save buffer, consult, compile, make the inquiry. So let's do that now. When you go to prologue, and take a new file. It asks for the name, first of all. This is 29.03. 29.03. We'll save it in the then open or consult here. Yeah. Now let's see whether we can set a goal. Capital that's true. But let's see whether we make some Colombo or something. Colombo is also capital. Why is that? We'll include the others also now. Berlin. Simple B. Remember? Atoms. Yeah, atoms. Third one is capital city Cairo. Just by typing, as you know, as you can expect, it won't count. If you say Pyro. False. Because still only this one is there. Paris. That's the only thing that is in memory. That will say true. So what do we do now? Consult or compile. Yeah, you can make. You see? Consult, compile or make. Compile or make. So let's compile and make. Right? So anything. But let's try Pyro. Yeah, not it. Because it didn't show any reaction. Right, then compile buffer. Yes, now it's okay. The green reaction came. Now let's try. It's true. Let's try Colombo also. So that is also true. That is how. So the database, the knowledge base is there. And if you just check, is this capital? Says yes. That is how simple form. Simple form. That's how it works. At this stage, you can't call it artificial intelligence, but that is an expert system. That's how they work. I must have to give everything, all the details, and then according to rules. There are interesting rules coming in now. All right. Task 29.01. Launch the editor, file new from this WI Prolog environment. Enter the three clauses as shown in figure 29.02. Then save the file. File save buffer as ex1. Then the querying. These are the queries we are doing. Capital City Paris will give true. Capital City London false. Correct. Let's try that again. Make 100% sure. Capital City London false. Because we are not given it. Then the next. Run your own queries. You first need to consult the knowledge base. File, consult from within the Prolog environment and then compile. So that is WI Prolog uses the prompt question mark. This in our own here question mark and the dash. That's a prompt. Yes. Sample queries in Paris says Paris is a capital city. London is not a capital city according to the knowledge base. It's like if you are taught that London is a capital city when you're small in school, then you know it. If somebody asks, is London a capital city? You say yes. But if you didn't go to school or in your school, they didn't teach you when you were small, before you start reading news and all that, general knowledge, then if you don't have that knowledge, you will say no. Simple as that. If your query does not get a response, check that you have consulted your knowledge base. Green text in figure 29.03. Yeah, that's right. That's what I told you. That's what happened earlier. I told you since this green response didn't come, it will not work. So you have to check. So these things happen. That is why they are giving the, the medicine also here response. If your query does not get a response, so sometimes you might have to repeat or something. Check that you have consulted your, or you have forgotten, consulted your knowledge base. Then use lowercase letters appropriately. use the full stop at the end of your query. So now we come to prolog variables. So all these are atoms, right? The predicate and the the other. What is it? And then when you declare something, remember predicate and the argument. Yeah, capital city Paris. This is the predicate, capital city, and the argument is Paris. So these are all, all the arguments should be in simple letters. But when you can try this. These are all here the double. Paris is a city in have another one. It's like Paris is a capital city in France. How does that happen? Because first you say capital city is Paris. Paris is a capital city. Yeah? Paris is a capital city. This one, what is he saying? Paris is a city in France, right? Paris is a city in the country France. So now it is connecting. Now this Paris and this Paris is connected, and then it says capital city. It's a capital city in France. Paris is a city in France. This one is Paris is a city in France. But what happens when you query? In which country is Berlin found? So for that you say city in country. Berlin and see the country. That's a variable. Why? The C is capital. First letter is capital. And the answer will be country equals Germany. Country equals Germany. Right? So let's try that part. We already have these three. We'll add this also. Save as. Let's do the normal way. Make. Then the green response came. There is an error, but we can check it out. What do we check? We are going to use a variable, not in the declaration, but in the goal, in the query. Copy this, then it's easy. Or let's type it. In country. Remember we did city in country, Paris, comma, France. City in France. So we are going to put this country. Where is Paris? So with capital C, press center. It says country equals France. Where is this? Um, Paris. Paris is in France. How do you get this? This country we put. It's like asking or getting the answer to the variable country. Country equals France. So here the other one is country equals German. So let's feed the others also. Now this is interesting. There are two in Germany, Berlin and Munich. Take one by one. That's okay. That was the early one. Now let's add one by one. City, country, Berlin, Germany. It is not so easy as Python. Okay, let's try again. Save buffer. Compile. Yeah, this time it's okay. So we had another one. Maybe while I was copying, you better space or something in between. That must have been the problem. Yes, and another one. Second city in Germany. All right. Let's see whether without saving the buffer, they will. Yeah, without saving also, it got okay. If you say make, right? Let's try out now. It's a variable. Now let's try the other one. Which cities are in Germany? So city in country, that's the same declaration, predicate here. City in country, city and Germany. Now this time, we are putting the C capital. The variable is city and the country is Germany. So whatever the cities which are there in Germany will come. Like city equals Berlin, city equals Munich. Right? So let's try that. Save time, you can copy this. And also to save errors. But sometimes copying gives errors. So it's a 50-50 chance. Press enter. It says city equals Berlin. Right? Now see, when there is more than one answer, you need to type a semicolon after the first answer. And prologue will give the second answer. Right? So remember that also. Yeah, I put a semicolon here. When the first answer comes, Berlin, but we'll try again. Yeah. Yeah. C is capital in the capital city. So it's a variable. City equals Berlin, and I put a semicolon. The moment I put a semicolon, the other one also comes. Munich. Munich. So Berlin and Munich both come. Semicolon has the meaning or. So either Berlin or Munich. Now here is a task. Using a knowledge base, consider the following knowledge base. Vegetable. Aubergine, right? I've not heard of even. Here's a comment. Aubergine is a vegetable, right? Comments are like this. Prologue, slash and asterisk, and closing other way around. Asterisk and slash. So how do you call this? Aubergine is a vegetable. That is how it's out. So potato is a vegetable. Tomato is a vegetable. And here, chicken is a type of meat. Chicken is a type of meat. Beef is also a type of meat. Lamb is also a meat. Then ingredient. Tagine contains 250 grams of aubergine. So the ingredient tagine has 250 grams of aubergine. That's how we can take it. And the other ingredients also. Tagine has this also, about 100 grams. Then stew has beef 400 grams, and stew also has potato 600 grams. And when we can check the ingredients of a tagine by asking ingredient, tagine, ingredient, comma, amount. What? Two variables here. What is ingredient in tagine and what is the amount used? So let's create this one. This is example 29.01. Yeah, it's there. Worked example 29.01. So we can on that now. And straight away say consult one. You have to give that place, the name of the file. Worked example 29.01. And it gives a green light here. So we can do a query. Tagine by asking ingredient, tagine, what is the ingredient and what is the amount. So it says ingredient, tagine, ingredient, amount. Then it should give the answers like this. So let's try that. Ingredient. Open bracket. Tagine, comma, capital I for ingredient, which means it's a variable and we should get the answer for that. Plus amount also. Lay, therefore that is also a variable and that also should give the relevant amount, number of grams. I'll put the full stop and press enter. Here it comes ingredient equals aubergine. The first one, the first thing is ingredient is aubergine and the amount is 250 grams. Then if you put a semicolon, second ingredient tomato, and the amount, the weight is 100 grams. Just like this one here. So it's interesting and you can download this. It will be there in the website, your course page. You can download it and then try like this. Now comes the anonymous variable. Ingredient, tagine, ingredient is the capital I, so it's a variable. And this is an anonymous variable, just the underscore. So if we are not interested in the amount of each ingredient, then you just put a underscore there, anonymous. So there's no name for that. And we try that one. They are not showing anything, but let's try it. See? It doesn't give the grams, number of grams. So we're not interested in that. So why don't you think like we should try without the second parameter? There is an error. See, there are definitions for ingredient arity 3. How do you see the meaning of arity? This has been defined internally like this ingredient slash 3. So here it's only 2 we are giving. Correct one is this 3. Three arguments in the parameter. 3 arguments. Here we are giving only 2. That is why we have to give the underscore. Sorry. You have to give the underscore as a, and it works and it won't give any amount. What if you put some dash or something instead of underscore? Then it says false. All right. So calls, now we are coming to rules in Prolog. Clause is of the form head, this and body. Calls to predicates, rules, goals. Body is the calls to predicates, rules, the goals of the rule. A predicate is either true or false based on its terms. If the body of the rule is true, then the head of the rule is true too. Well, let's look at the body and the head, body, and the tail. Oops. Yeah. Third example, 20.02, using rules in a knowledge base. Consider the following knowledge base. This is Fred is the father of Jack. Fred is the father of Jack, parent. Fred is father of Elia. Fred is father of Paul. Dave is father of Fred. We know that G is a grandparent of S. If G is a parent of P and P is a parent of S. It's not so difficult. Simple thing. Right. G is grandparent of S if G is parent of P. G is a parent of P. G. P is a parent of S. So this P is a parent of S. Okay. S, sorry, G is a parent of P. So this one is parent of P. This is the parent of S and this is the parent of G, P. Then what is this one? With him. This is a grandparent of this. Okay. Son or child. I put son because S is there. That is the child, grandchild, no? Or child of P. S is the child of P and P is the child of G. So G is the grandparent of S. So that is this. We know that G is a grandparent of S, G to S. Right? If G is a parent of P, G is a parent of P, and P is a parent of S. That's a simple logic. And your logic and all that, something like that. This is the logic, what you call logic. We know that G is a, sorry, we could write this as a rule. Grandparent, G, that means G is a grandparent of S. If G is parent of P and P is parent of S, right? However, in prologue, the if is replaced by this semicolon, this colon and the dash. And the word and is replaced, the condition and is replaced with a comma. So the final correct statement in prologue will be G is a grandparent of S if, this is if G is a parent of P and the semicolon here, sorry, the comma means and parent, P is a parent of S. That's nice. Huh? How we arrive at this? Again, G is a grandparent of S if G is a parent of P and P is a parent of S. Nice logic. I really like it. A person has a sibling, that is brother or sister. If they have the same parent, we can write this as the prologue rule. A is a sibling of B if this is there, the if is there, if P is parent of A and P is parent of B. So if P is a common parent of A and B, then A and B should be siblings. If we run the query, sibling Jack is a sibling of whom? X is capital X. So we should get both. But Jack is not given here, so we'll have to do that. We have to feed. So let's try from here. Our practical should start. Fred. Yes, we can try these two. Fred is a common parent of these two, all three. And also, Dave is a grandparent of these three, isn't it? But all that is not fed, but that is the logic in this. So let's try that one. This is 29.02. Let's see whether that is also there. Yes, that is also there. We are lucky. Straight away, we'll consult that. just give, but let's check it out on our own. We have this. How about mm, we can use these. Ah, no, no, we have not done the. We can only find out this because siblings and all that we have not given the other combining things. No, but we can check it out an earlier one. What? Who are the children of Fred? How do we do it? Parent, Fred, child. Put capital CHILD so that I'm using a variable to get the children of Fred. Up, press enter. So one came, one is Jack, first one, semicolon, Alia, semicolon, Paul, and that's all. Because Fred is, I mean, this is something different. So only these three are Fred's children. And Fred himself is Dave's child. And this combined the and operation, let's see. Here sibling. You can try sibling here. If they have the same parent, yeah, okay. So let's try this sibling. This is not connected here. Jack is simple, so it's not given anywhere. So we'll have to say that, you know, it's we have to correct our version. I will have to read our version in this. Let's have a look at the file itself. See what is open. Open. Can I work example 29.02? Check. Oh, that's the one that we did. Yeah, so that is there, but this is not done. That will have to make one. So here is the program for this sibling. A is a sibling of B provided, or if parent P is a parent of A and comma is and P is a parent of B. Parent is of B. This was not there. This came afterwards. Want you can check it out. Let it be. Can save some time for that also. Because what happens is we get the answers we expect, but we also get the answer that Jack is his own sibling. To avoid this, we modify the query to ensure that A is not equal to B. That is the meaning of this, not A equals B. Otherwise, Jack is also coming as sibling of himself. So let's run this and see. Mm, that is already compiled. And see being a sibling, right? So let's try this one. So a capital A, we are giving variables for who are the siblings. Jack, Alia. Second one is Alia, right? Remember? Remember we had that. Let's see. Uh, Paul also. If you look at where is it? Jack, Alia, and Paul. Jack, Alia, and Paul. So Jack's siblings, right? Alia and Paul. So so that is also done. Then 29.03. Write a knowledge base for your own family. You can include more predicates. For example, male. Fred is male. Elia is female. So that also. Now, if there are any, it's unlimited. Like you can have your own. If you are creative, if your imagination is good, you can create a full list of things like this. Predicates. Write a rule for father. Test your program. That is to you to do. That's a task. 9.03. Yeah, these things have to be done. Otherwise, we'll find it very difficult later. Then 29.03, adding a rule to a knowledge base. Using the knowledge base from worked example 29.01, we want to know which dishes contain meat. We are not interested how much meat, so we don't need to know the value of the third argument of the predicate, ingredient slash 3. Arity is 3 argument. We can write the rule contains like meat. And X contains meat if ingredient X is ingredient X meat is an ingredient of X, and we don't need this. We don't need this amount. And meat, what is the meat involved? This capital M is variable. What are the meats and what are the ingredients? The query contains meat X. Query contains meat X returns X equals 2. So what is this? Which has meat and all this, which has what is a what is a vegetable or the dish? What is a dish? It's a soup. It's a stew rather. It's a stew which has this. So let's see whether we have that 29 point worked example 29.03. Yes, that is also there. We'll open worked example 29.03. Yeah. Is it from the book? This one contains me text if it's this like that. So let's compile that also and see. Make what is a query? Our query contains meat x contains meat x. Warning, not a real error, the warnings, but we can sometimes it works. Even there is a warning. Yeah, it returns x equals to. I put a semicolon, sorry, I put a semicolon and it says for there are any no more dishes, only this. Try again. X equals 2. Correct? Right. Now we are coming to instantiation and backtracking. Prolog responds to a query with an answer, such as the one in worked example 29.03, x equals 2. We saw that a little while ago here, x equals 2. The equal sign shows instantiation. Equal sign shows instantiation. What is instantiation? Creating a, like in our object-oriented, we saw that it's a creating an object. How does Prolog use the knowledge base to arrive at the answers? One way to see exactly what Prolog is doing is to use the graphical debugger. Use the knowledge base from worked example 29.03. After consulting the knowledge base, start the debugger. That is debug, graphical debugger on the Prolog environment, then type trace. And then the goal as shown in figure 29.06. So let's try this. 29.03. Worked example. Yeah, this is one worked example 29.03. And follow this now. Consult after consulting the knowledge base. So consult. Right. So after that, what happens? Reduce the size of this. Consult the knowledge base. Start the debugger. That is, you go to debug. Where debug? Here in the other, like the shell. Debug. And here, debug, graphical debugger. Under debug, you have graphical debugger from the Prolog environment. Then type trace. And then the goal as shown in figure 29.06 here. Type trace here. Trace Who didn't come here? Because I did put a dot, full stop. So trace full stop will give this. And then what do we type? Contains meat X, our query. Here, look at this. Now this is the trace. Contains meat X. When it comes on the trace facility. Using the space bar, you can step through the program. When Prolog gives an answer in the Prolog environment window, remember to input a semicolon. So that Prolog will go and check for another possible answer. If you don't use a graphical debugger but type trace, you can see the trace in the SWI Prolog window as shown in figure 29.08. So that is the next one, will show without the graphical. There itself, you will have the trace, all the things. But here we have the graphical user interface, graphical debugger, interface. So let's try that, the space bar here. One is the one that the execution takes place. So now it's here. If X is X is the variable dish and the meat is ingredient and the quantity. Again, if I press the space bar, now I'm pressing space bar. Vegetable is aubergine. Now it just come here. The space bar again, and then now the last one, again space bar. Here the answer is given. The next line here is checking. Has given the answer here. X equals 2. After tracing, it has given the answer here. Interesting change from the imperative programming. You put a semicolon if you need, if, yeah, nothing. Don't use the graphical, yeah, that's, if you just put trace here, without using the graphical interface, then you will get like this. Call, then if it fails, it shows that it's not a good selection. Then you go on checking, redo, fail, call, like that, it goes at the answer. The following terminology is used when discussing a trace. Call is the initial entry to a predicate. This is the description of this output here. Call is the initial entry to a predicate. Creep indicates that Prolog is moving to the next predicate. Exit is a successful return. All those things are there, right? And a redo indicates that the predicate is backed into for another answer. Then fail indicates that Prolog can find no more solutions. Right, then recursion. Here also you get recursion. We have already done recursion earlier in the normal, in Python and all that. Recursion for declarative languages is where a rule is defined by itself, or more precisely, a rule uses itself as a sub-goal. We want a rule that defines whether person A is an ancestor of person B. If A is a parent of B, then A is an ancestor of B. Correct? No? Similarly, if person A is the parent of P, who is a parent of B, then A is an ancestor of B. This is true for the parent of a parent of a parent of B. In general, if A is a parent of X and X is an ancestor of B, then A is an ancestor of B. We can write this information as the rules shown below. Real logic. Yeah. A is ancestor of B if A is parent of B. That's a base case. If this happens, then we know that A is a parent of B. But, and then ancestor, A is an ancestor of B if A is a parent of X and X is ancestor of B. That's a general case. So going on and on and on until it comes to this place. Then it's finished. That's a recursion. Remember, a recursive rule must have a base case, and reach the base case after a finite number of calls to itself. Task 29.04, ancestor rules to the family knowledge base and check that the following query gives the correct results. A is the ancestor of Jack. So that also you can do. That's for you to do. Is another worked example. Creating the factorial function in Prolog. Factorial in chapter 24, worked example 24.01, we programmed the factorial function using recursion with imperative programming. You can also program this function using recursion in Prolog. So factorial 0, 0 is 1, no? 0 factorial is 1. The base case, 0 factorial is 1. Factorial n result will, if m is n minus 1 and this comma is and, factorial m and comma part result of m, part result is part result into n. That is how you define it. Yeah? Base case is that, then otherwise result equals n factorial, assign n minus 1 to m, then part result equals n minus 1 factorial, and result equals n into n minus 1 factorial. So that's the general case. Here is the program for creating the factorial function Prolog. I have already created it earlier. So as we went through this, these are the ones that are exactly, I have copied them. I have typed everything same. And yeah, let's consult it or make done. So let's enter the code from worked example 29.05, that is this one, into the Prolog editor, save it and consult it, and post the following query. Factorial 5 answer. You get the correct answer. Let's see. Factorial, that's a function name. 5 comma answer, capital A. Now let's see. Factorial 5 answer 120. Let's try factorial 4. So, what the answer to that? 24. So likewise, so even in this, it's interesting. We can, even in declarative programming, we can do the recursive function for finding out the factor. There are lists also in this. Any non-empty list can be thought of as consisting of two parts. Non-empty list contains of two parts. The head and the tail. The head is the first item in the list. The tail is the list that remains when we take the first element away. So head is the first one and then the rest is the tail. This means that the tail of a list is always a list. So the rest also becomes a list. Head is only one, but the rest is a list. So lists are manipulated by separating the head from the tail. The separator used is a vertical line like this, a bar. Right? If Prolog tries to match head and tail like this, head, separator, and T, this is a list to car, lorry, boat, ship. It will instantiate H, H to car. That is the first one. Always the head is the first one. Car and T to the balance. The tail is lorry, boat, and ship. Lorry, boat, and ship. That's the way it does. So the clause definition, show head and tail, H separator T, comma, H, T can be used to pose the query. Show head and tail, Fred, Jack, Emma, head, tail. Prolog responds with head equals Fred, tail equals Jack and Emma, the balance part, these two. Let's try that also. Sorry, that is the format. This is the real query. So 10.09, or we'll make it list. Let's see whether I've already done it. No list. So let's make a new one. Head and tail is a list. Red, comma, Jack, comma, and head and tail. So let's save the buffer and make, and let's see the query. So this is the introduction, and we'll compile buffer. Then we'll post the query. This query. Yes, head is friend. See this head is a friend. This one, and the rest is the list balance list tail. Jack and Emma. Jack, Emma. So like that it goes on. Huh? Head, tail, and the balance is head and tail. So yeah, prolog response like this here. Head equals Fred and the tail is Jack and Emma. Cost definition, mile is 1, 2, 3 can be used to pose a query. Mile is HT. Prolog response with H equals 1, T equals 2, 3. So this is the that is the this is the definition, class definition. Save buffer, compile, right? Then let's see the query file is head and tail. This A equals empty list. We used to pose the query empty list 1. So like that it goes on. Product response with false because it's empty, no? There's no elements there. So one that will be false. Then list processing predicate. The built-in predicate member A, comma B returns true if item A is in list B. If it is there, it will be. So member C, comma is the list. A, B, C, D, E produce true. And member X, comma A, B, C, D produces X equals B, C, D. Why? Because X is the variable here. We are asking for this, and the whole thing is given A, B, C, D. A, B, right? So yeah, that's a very easy thing, but see. So let's try the list processing predicate now. List processing predicate. The built-in predicate member A, comma B returns true if item A is in list B. So if A is in list B, then it will return true, like this one. Member C. Let's take it from the textbook. It will be easy to copy and paste, so save time. Yeah, this one. So this append, it's from here itself, we can check it. We saw this, we saw this, and we did that. Now we are going to, yeah, A, B, the built-in predicate append A, B, C joins list A and list B and produces list C. It's like that. And in fact, we can no need of file for this kind of append A, B, C joins list A and list B. Just connect A and B and produces list C. That's what happens. Then append A, B. What does this do? A, comma B, that is one list, comma C and D to my list, right? What happens? Produces my list, the last one here, with A, B, C and D, everything. C and D appended to A and B. See? My list equals A, B, C, D. All four came inside. Then append first list. C, D, A, B, C, D, all these are appended to A, B and C, D. A and B. No more, right? Producers, first list C equals A and B. That's right. List processing, predicate, member. Now early it was append. List processing predicate, append. Member A, comma B returns true if item A is in list B. So member will say member C is present in this list. So let's see whether it really works. Shall we make this something else? K. Whether K is in this list. You see X. Member X, it will give all these. These are variable that we want the answers. The semicolon, it will give more. All the A, B, C, D, all the members are given. Then it's another list processing predicate, write and read both. Built-in predicate, write A, outputs A to the screen. So example here, write message. We can include the message here. Say hello. Hello world. That's an output. So this is how you do an output in Prolog. Right. Right. This output. So it has a variable in something into X. Read A reads a value from the keyboard into variable A. See, that's yeah, read A. That's interesting. The input. Remember, put the full stop here, finding everything, right? Otherwise, it will not. Now, what is happening? It's waiting for the input. So, is a name or something, right? And full stop. True. Right. Read name, wait input from the keyboard and instantiates the variable name with that value. Note that the input must start with a lowercase letter and not have spaces or be enclosed in quotes. N1 moves the output to a new line. So if you want a new line to come, then you have to put N1, NL, new line. We can write user-friendly program using the read and write predicates. So this is a very interesting program. But before that, let's see whether this we did do it's recursion we did do. Yeah. 'Compile the buffer. Then how do we check? How do we check the answers? Right? Can say factorial 5 comma answer capital A, right? Five comma 920. See? Now if you want to check 4 factorial. All right, so let's come to the most interesting program here. Note how the interface with the user in the code below. Note how the interface with the user in the code below is written as a rule with the separate steps separated by commas representing and. Remember? Remember if and those things you remember. Assert one adds the clause given as the argument to the knowledge base. All right, then retract all one argument. With one argument takes a given clause out of the knowledge base. So the next time the program is run, the new facts will be added and used in the goal. So here is the program. Whether good with the knowledge base, right? Whether good, temperature high, uh, humidity dry, sky. The bad. See, let's read this again correctly. Weather is good if temperature is high, humidity is dry, and sky is sunny. Weather is bad if humidity is wet, temperature is low, sky is cloudy. That's the interpret. Go. Right. Is the temperature high or low? So this right is what? This is a prompt, like prompt on the screen. Is the temperature high or low? And read. This is taking the input to the variable temp, and NL is new line. Right. Is the sky sunny or cloudy? So take them to that. Right. Is the humidity dry or wet? Read humidity. Then assert temp. That is assert with one parameter, right? Assert temp. So you go to the this one and check how, what are the rules. Then assert sky. With the sky, humidity, weather, then weather. That will give you the capital W. That will give whether it's good or bad. From this, both of these, it will come to the correct one and then check. Good or bad, it will be here good, this is bad. Right. The weather is, right, again, another one, weather, capital W. So it will give good or bad, one of them. Then retract all. So if there are any more new things like getting in, and retract all humidity. So there is a program. This one, yes, here it is. It's fed, and then let's consult it or compile. Yeah, that's compiled. Now you type go to run this program. Oh, I will start. We'll say go. We'll say go. Ah, sorry, I didn't put the full stop. I must always remember that. So I had to compile this again because there was another program. Compile buffer. Compile. I'll say go. Go. The temperature high or low? What shall we say? We'll say high. Like a normal program, isn't it? But full stop, don't forget. Then is the sky sunny or cloudy? Let's put sunny. Full stop. It's a humidity dry or wet, right? Weather is good. See, weather is good. What happens if we mix up? So again, go, full stop. It has temperature high or low. We put low and then mix up all. Low. Is the sky sunny or cloudy? The first parameter, sunny. Full stop. So whether it's bad, right? Even if this is low, uh, even if this is sunny, because wet and humidity temperature low, that means weather is bad. All should be good for the temperature, the weather to be good. All right, so that's a very interesting. mm, In fact, at the very beginning, when I started learning, I never imagined that this kind of programming can have an interface like this. So here is a final task for you. Test the recursively defined rule by right list, parameter 1, to output the elements of a list. Right list, and this is an empty one. Right list H, the head, separator, and tail. If right head and NL and right list, the new line, going to new line, put the header, the new line, go to the new line, and right list T, tail, go the tail. So you can give a, there's the recursively defined rule. So these are recursively designed thing because right list is there coming again. Right list, right list, right list. So when you encounter this right list, it's a test because like the head is separated, no? Head is separated and then the tail is without the first item. So when this happens, the first item of the tail will get to the head, then the rest. Likewise, it goes on recursing. So that was quite interesting. And here is a summary of what we learned. We'll do soon before you forget, and we'll get a very good idea of it. Quite the course, and I wish you all the best for your year that bye. Good luck.